today, this is going to deal with doing guys, it's not doing anything like arithmetic sequence series or geometric right now. This is simply going back through the sigma notation stuff. Okay, just finding terms of a sequence defined for you, so on. Okay, so the basic idea of what you're dealing with today is just, here's the sequence, right? And sequence meaning you've just got numbers in a specific pattern, okay? Something like that. Now, what you guys are going to have to do, these are the things where they give you the number pattern. Basically, they'll say, okay, here's your pattern numbers. You write the formula for the nth term. All right, and if you remember, guys, you know, honestly, everyone will approach this differently. There isn't like a set method to do this. On the examples I have, not necessarily this one, but on the other examples we'll do, I'll kind of talk through it as I would do it. But what you kind of have to understand is come up with your own method when you write these out. Okay, so just like if I looked at this 2, 4, 6, 8, 10, you know, I can obviously tell the next number should be 12, correct? Make sense? So everything would be going up by 2. So when I say write the formula for the nth term, right, nth term would have to have n in it. I know that my n is going to be multiplied by 2 because everything's going up by 2. So this is just the basic general term of 2n. All right, so this would be what the nth term is, right? And this is the sequence. And remember, guys, it goes, catch up. First term, right? Second term, third, fourth, fifth. So A sub 1, A sub 2, 3, 4. So what the nth term does, like what the formula does, is it gives you a formula to find like whatever term you want by just plugging in the number for n. So like if I said find the 100th term, a sub 100. That would be 2 times 100, which is 200. So I know 200 would be the 100th term in this pattern without writing out all 100 of them. Yeah, whatever differences between them is what you're going to multiply by. So like the first term would be 2 times 1, second term is 2 times 2, 2 times 3, 2 times 4, 2 times 5, so on. Like this would be a pretty basic pattern, okay? And usually with the basic ones where you realize there's a common difference between them, right? Like an arithmetic one. You could break it down into something as basic as whatever the difference is, like 2, 3, 4, whatever. That's what always is going to be multiplied by n. And you might have to adjust it a little bit, like if it doesn't start directly at 2. Like if this started at 1, like if it went 1, 3, 5, 7, 9, then it would be 2n minus 1. So I'd be taking 1 away from all of them. But the difference between the numbers would still be 2. From 1 to 3 it would be a difference of 2. 3 to 5 would be a difference of 4. All right. Now, the basic thing I want to point out here that before I do the examples like that are going to be, just remember what the terminology is. This is like the nth term. N is whichever term you're at. Like first term, you're plugging 1, 2, 3. All right. And I wanted you to just understand that when you see something that resembles that, that's like their formula for the nth term. So, to start with. To start with, this would probably be like the basic things to do. Where they give you a sequence there, they define it for you, they tell you what it is, and then they just say find a certain number of terms. In this case, it says like find the first 5 terms and then the 100. Which again, it's key to the idea that if you put the first 5 there, you can see a pattern. if I had to go beyond this, but when I do the sums, maybe this would come more into play. But it doesn't go beyond you just plugging in. First 5 terms would be n equals 1, n equals 2, 3, 4, 5, and then n equals 100. And you should realize, like with both these, like on the first one, if I see this here, I know all my differences, like the difference between the numbers is always going to be 2. Because everything has to increase by 2 to be 2 times n, multiplied by 2. So I don't technically have to go in and plug in the numbers each time. I could do like 1 and 2 and 100 and probably get all the rest of my answers I need. Like if I did that, if I plugged 1 into here, so a sub 1 on the first one, be 2 times 1 minus 1. 2 times 1 is 2, correct? Minus 1 is 1. If I do a sub 2, that'd be 2 times 2 minus 1, which is how much? 3. So I can already tell that there's going to be a difference of 2, just like it says right there. So go 1, 3, 5, 7, 9. That would be the first 5 terms. And then the 100th one I would probably want to plug in. Like I would go 2 times 100 minus 1, which is 199. If you can figure out the patterns to them, guys, you know, it's going to save you time. It's not a necessity because they have a formula defined for you, so you can plug everything in. It just might make your life a little easier there. And then, like, if I did the other one, so for this one right here, I do it c sub 1, right? Be like 1 squared minus 1, which is how much?
0.
All right. If I plug in 2, it's going to be 3. 3 would be how much?
8.
8.
15.
15?
Yes.
Right?
Okay.
And then the next one is
24.
4. And then the 100th one would be?
Would it be 9,999? Is that 4 zeros? Yeah.
Yeah.
No, listen.
Well, 100 squared is 100 with 2 zeros at the end. 10,000.
Oh, right.
What are you trying to say, Gabby?
I'm trying to say that.
You're like stupid.
No, I'm not.
Okay, now, the next part, okay? Like it's going to build as you go, okay? The next thing will be, okay, you found terms, you plugged in stuff, they give you the formula. Now you work backwards from where they give you the sequence, and then they say, here's your sequence, you write me a formula for the n term. So basically what they're saying is you come up with something that says a to n equals, and you write out how to do it. It could be something like 2n plus 8, I don't know, 10n to the 5th power, whatever ends up the pattern being. All right? Like I said, the easiest thing to do is if you see a common difference, like all the difference between these numbers is how much? 3.
N plus 3.
Time.
N
So
times
if everything's increasing by 3, I know it's going to be a 3n. The only thing you have to adjust for, and this only works if they all go up by the exact same amount every time. Because anything else, like if the amount goes up, changes, then you're dealing with like something raised to a power, so like an exponential kind of thing. The only thing you have to account for is just look at the first term and see if you have to add or subtract it. Like in this case, they got a sub 1 equals 1. So if I just stuck with this formula and plugged in 1, I would get 3 times 1, which those aren't the same. So what would I have to do to this number to get it down to what I wanted?
minus 2.
That'd be your whole point.
Yeah.
Okay? So this, stuff like this, where you realize the difference between them is the same, you can always stick that in front of n, and then just at the end adjust, either adding or subtracting what you need to by just looking at the first term. Those are the easy ones. All right? I'll rewrite the formula, but this is going to be the next one. This was 3n minus. Okay, with this pattern. Not negative 2. It's to the end, so yeah, it is. All right, the pattern here, if you look at it, you said it was to the end, right? Well, not, you said, okay. There's going to be a negative involved here, obviously, because you see it's changed. If you wrote it this way, I can see it working. If you didn't group it, you'd have issues with it. You have to group it here. All these guys are raised to the nth power, right? That's 2 to the first power, 2 squared, 2 thirds, 4th. The only issue here is you have the alternating sign, which you can put the negative in front of this one as long as it's grouped. If you wrote it this way, if it's ungrouped, remember that negative is going to stick with it every single time. So like if the pattern was like -2, -4, -8, -16, you could write it this way. With the alternating signs, you do that. One way to get around when you have alternating signs, you don't want to think about where the parentheses go. If you have alternating signs in your formula, you can always put that at the front of it. If you can come up with the basic formula and just throw that at the front of it, this will always account for alternating signs. Okay, if it goes negative, positive, negative, positive. If it goes plus, minus, you have to change that to a plus 1 if it started with a positive number. Okay, but just kind of keep that in mind. Your patterns aren't going to get much more involved with this. Like you coming up with the end term, the general rule for these, it's not going to go beyond ones that should be fairly obvious. Like ones that have a common difference like this one did, or this one that is a specific number raised to a power. Okay? So they should be fairly straightforward. Alright, but now like whatever process you guys come up with, as long as it works, it's not really working. Alright, next thing is this one. Okay, the recursive sequence. The word recursive, if you forgot what it meant, if you've seen it before, it just means that the next value in your sequence depends on the previous value. You have to have a starting value in this case. You have to know what the first term is to even complete this specific sequence. So whatever value you get for the previous term is going to affect the one that you're coming up with. So if you have to find like the 7th term, you need to know the 6th one. If you need to find the 10th term, you need to know what the 9th is. All right? Example 1 would be one like that. Okay? Anytime you start seeing this involved in your formula, you know it's going to be recursive. Because n minus 1 always means the preceding term, the one right before this. So if I did like, if I found the 4th term, it would be 3 times whatever the 3rd term is, plus 2. If I found out what the 50th one is, it would be 3 times the 49th one, plus 2. Okay? Yeah, so and for these guys, they have to give you the first one, because if I start doing it, that's first term. If I start writing out what they are, like if I go to the 2nd term, right, this would be the 2nd one. Now the 2nd one would become 3 times the first term plus 2. They're telling me what to start with. Okay? So I know that that first term is 1. So if I wanted the 2nd term, I would go in there and go 3 times 1 plus 2. 1 plus 2 is 3, correct? Right?
Yeah.
Times 3 is All right? Now this term right here would factor into my third one. So right now, if I did it, I've got first term is 1, second term is 9. My third term would be, according to the formula there, 3 times the second term, because again, it's 3 is my n, 3 minus 1 right there is 2. All right, plus 2. Right here, I just found out my second term is 9, so 9 gets plugged into there. You have to have the last term to get through. So this would be like 3 times 9 plus 2, which is 33. Then the fourth term, up here I said, 3 times the third term plus 2. So my third term is 33. 33 goes into right there. I do the fifth term, whatever this is, comes plugs into there. So okay? Olivia, what do you
I understand that, but if you really have to find like A of 50,
You're not going. What we do is you're
it'll
not
only
going to
give
find.
you like lower ones.
Yeah, if there's one like this, there is a way of doing the calculator. I don't think we're gonna have time to deal with it today. I'll deal with it next time.
But you really
So
have to.
if I ever gave you one like this that was recursive and I said find the 50th term, I would expect you just to go to the calculator.
Okay, but
You're not gonna write out 49 terms.
But like for lower ones, like up to 4 or 5 or whatever, then you just do it like.
Yeah, you just start at the first one and write them out. You would have to have all those in order.
Will we learn like at some point how to do it on the calculator?
Yes.
Okay.
I don't understand the three, where you have the 3 and the parentheses A minus, the n minus 1, what is that? I don't understand.
This is the formula to find the n term. Like before we had,
Yeah, but what do you substitute the n?
like if I did this one right here,
Yeah.
it's a sub 4, so that means my n is 4. So all this is doing is saying I'm going to put a 4 there. 4 minus 1 becomes 3. A sub 3 is the third term. So the little sub thing is just telling you which term to look at.
Oh, okay.
The n minus 1, but n minus 1 just means look at the one right before. If it was n minus 2, then you'd have to have 2 before. They can do anything preceding it if it affects what the new value is. Guys, why?
Would you think that number is because there's you plug in?
Like
From
8?
the previous one, yeah.
Yes. And if I had you do like the fourth term, you would have to do all these steps prior to getting it. They take longer than the other because they depend on the other values.
So you start out with A sub 1 and then you work your way towards that and you just keep plugging it in for A sub
Got
1
it.
because you have to subtract 1 from the other way. So you got A sub n.
They have to do it. You have to start with it. Yeah, you have to start with it.
Alright.
Okay.
Oh.
Oh.
I was like almost about to be done.
I'll go back. All right, next thing, okay? The partial sums. Okay, so what it'll do is, like, the stuff prior to this is pretty much everything you'll do in terms of just sequences with finding terms. Like finding the fifth term, sixth term, whatever. Everything after this is going to deal with finding sums. The first thing you need to know is partial sums. Partial sums are you just finding sum up to a specific term, like sum of the first 5 terms, sum of the first 4 terms. Not finding a sum to infinity with this. Like there are times you might have to do something else. Now, the way that you're going to have to approach this when they do partial sums is they're going to have you build it like one term at a time. Like you'll do the sum of the first terms, which is essentially the first term. Then you do the sum of the first 2 terms, the sum of the first 3, first 4, first 5, so on. Okay? And what'll probably be asked of you is once you do that, they'll say, okay, look at the numbers that you get for the sums and try and find a pattern to it. Try and come up with a rule for the sum so that you can go ahead and plug in. Like if I said some of the first 50 terms, you could just take 50 and plug it into your formula. All right? But we'll just stick with this one. So this term, guys, you can't see that it's 2 over 3 to the n. All right, so if I said the first 4 partial sums, basically, in the way this will be listed in the book, is they'll say, it'll be like S of 1, 2, S of 3, and then 4. All right, which means sum of the first term, sum of the first 2 terms, sum of the first 3 terms, sum of the first 4. The bottom number just means how many terms you go out. So since I'm saying the first 4, I need to find the first term, I need to find the second term, third, and fourth to complete this. Okay, so the first term would be 2 over 3, correct? Right? What would be my second term? 9. 2 over, and then 2 over how much?
Okay, wait.
What's 3 to the 4th power?
81.
Oh, yeah.
81?
Yeah.
Okay. All right, so as you're writing these out, like this would, if anytime partial sums comes up, or they talk about finding sum of terms, all of this work is expected to be there. So like the sum of the first terms is just the first term. Sum of the first 2 terms would be, those added together. Sum of the first 3 would be, those added together, and then 4 would be the first 4. And it's not asking me to go beyond this. It's just asking me to add these things up. So, you literally need to add these up and make sure they are in fraction form, guys. Okay? Common denominators. Either that or, calculator, a little fraction button up in the calculator. Big, this button on the calculator says math. That's a lot of good stuff. But anyway.
Oh, that's where the absolute value thingy was.
No, my son did that.
Yeah, my son did
But it doesn't graph. We don't like it.
No, mine.
I don't know.
I don't see that.
Does it look white?
It does like I can graph like
Then
something.
it's considered a graphic calculator. It graphs. It's a graphic calculator. Oh, it's just those little graphs, so we don't count those graphs. We don't like those graphs. Whatever. All right, so this one here, guys, obviously common denominator should be 9. 2/3 is 6 over 9, so that should be 8 over 9. Going down here. 2 over 3 plus 2 over 9 plus 2 over 27. Obviously, 27 is my common denominator, that is 1. What do these all add up to if you do 27?
26.
What is it?
26.
I got 18
Six.
over. No, I got 18.
It should be 18 plus 6 plus 2.
Wait, but don't you just do like 8 over 9 plus 2?
No.
You don't?
Well, yeah, 8 over 9 plus 2 over 22. If I change this to 27, that 8 over 9 is 24 over 9.
Oh,
All right. Then the next one would be, obviously, it's over 81. Sure. Yeah. Sure. What do those all add up to as over 81? 80?
Yeah.
I would hope so. Yeah, if I did the fifth one, what do you think it would be?
242 over 243.
242 over 243?
Yeah.
That'd be the next one. Guys, essentially, now what'll happen is they'll say, okay, you see there's an obvious pattern there, right? The numerator is always 1 less than what the denominator is. Okay? And they'll say, all right, now come up with the rule for the sum of the nth term. So I can always just take a number and plug it in. All right? In this case, the denominator, how do we get the denominator in all these cases?
right here.
And that's the denominator? Every single one of these, 3 to the first power is there. That's 3 squared, 3 to the third, 3 to the fourth. That should be 3 to the fifth. Okay? And then on top, it was whatever was on the bottom minus 1. Because it was 1. So that right there would be the pattern of the sum for that. And that's going to be asked of you. Okay?
So,
All right, so guys, big thing. Partial, when they say do partial sums, you list out all that they want you to do. If they say 5, you do up to S of 5. With 6, you go up to S of 6. They're going to probably ask you to do as many as they think you need to figure out the pattern. Okay? 4 is probably the least I would ask you to do. All right? I think there's only one other thing I'm going to remind you of. And that's this. Why? It's easy today, though. You just think you're not doing anything big with it. Guys, just remember the sigma notation. All right? Sigma notation is essentially the same as what I just had up there. It's just a different symbol. Like S sub 4 that we just had would be the sum of the first 4 terms. If I translated that into a sigma notation kind of thing, the one that would look like, there's my S. Start with the first term, go up to the 4th term. And it would be like N equals 1 or K equals 1 or something like that. The difference is, okay, the difference is on this side you would have the formula for it. Like if I did the one I just did, it would be 3 to the n minus 1 over 3 to the n. So if this right here, right, like this way that's notated would be essentially the same thing as the S sub 4 that I just did. The difference between them is you're not going to sit there and okay?
Wait.
Alright, so what?
What is that thing on the bottom? The n equals 1 or k equals 1?
Tell me where to start.
Oh. So
It's probably going to be K. It needs to be
Never mind,
K.
it's absolutely.
Alright, so guys, the big idea is if you see the sigma, it's a sum. This is how you're finding the terms. Okay? K squared would be how you find the terms. So it's like the rule to find the terms there. Like 1 squared is the first term, 2 squared, and so on. It's just a more condensed way for them to write it out. It's basically taking the rule and putting it together with how far they want you to go to sum. Okay, it's just a condensed way of writing sum, or add up the first so on term. So I mean, instead of me saying, find the sum of the first 4 terms for this general rule, for this sequence, I can just write that. Right? Which would be me doing, starting with 1. This is the start. This is the starting point. Okay? 1 squared, and then you just work your way up to the end. That's the ending point. So I go 1 plus, then I plug in k equals 2 squared, and it's just a matter of you add each term, whatever it is. 3 squared plus 4 squared. 30? Is that right, 30? Okay? So the biggest things here to remember, it's probably, that's going to be defined for you. They'll tell you the formula. That's your start, that's your end. So whatever number they want you to end at, you just keep going until you reach it. And that you just plug in exactly what they say.